So good morning, good afternoon, everybody. What we'd like to do is kind of introduce DRS Daylight Solutions and what we do and what we're providing in this kind of quantum fabrication services. Daylight's a little bit further up the food chain. What we do is design, develop, transition to production laser sources and subsystems that can be used in quantum information sciences. So full service from the design side, transitioning all the way into production. If we look at the quantum ecosystem across the board, there's a strong need for lasers and sources generally that have frequency stable and intensity stabilized capability. The team that we've put together, we've been here for about 17 years with well over 100 years of experience in transitioning semiconductor laser technology into subsystems that go into systems. We're vertically integrated with design of the semiconductor gain media itself, fabrication, full capability, but more than that, the ability to integrate micro-optics with it and do the processing and packaging and setting up a pilot line that allows one to generate these stable sources and subsystems that can be used whether you're doing quantum sensing or quantum computing. The experience really is to transition from components with very high TRL. We're at TRL 9 in many cases. We've transitioned these semiconductor laser-based systems into full rate production with MTBFs well over 7,500 hours, integrating visible and near IR, shortwave IR, and even midwave and long wave. We've done devices from the UV all the way out to 12,000 nanometers. But more importantly, we can design the die at the die level to include DFBs, DBRs, integrate then those chips with on-chip amplifiers, switches, et cetera, and then hybridly package them with very, very low swap, robust micro-optics, whether they be modulators for modulating and Pound-Reaver Hall locking, closing the loop, temperature control, wavelength control, and integrating them into the system. So the services we provide is that engineering services to understand your system's application and transition it all the way into production by doing rigorous engineering flow down of requirements into the modules that are necessary. This is an example of the kind of thing that the quantum ecosystem could benefit from. Shown up here on the upper left is an example of a very small form factor, hybridly integrated, high TRL, robust package with multiple semiconductor gain media inside the package, wavelength A, wavelength B, with the ability to integrate into those die, as I said, grading stabilization, DBRs, DFBs, modulators, et cetera. All the micro-optics necessary to get multiple wavelengths coming out of the package. Doing frequency control if necessary, doing multiple wavelengths if necessary, doing broad tuning if necessary with high frequency control or low frequency control. Jamming, dozens of die into one very small footprint. But the approach is a comprehensive approach, working closely with the systems integrators to identify what is your system. Do you want to have a quantum source in a rack mount? Do you want to use it in a clock? Do you want to use it in a P&T application? We integrate frequency control package into the box, call it a part in 10 to the 6th to a part in 10 to the 7th of wavelength stability, but then go and integrate electromechanical, optical, and integrated packaging and do it in a way that transitions to commercial production, shown here as a pilot line of a multi-sources with passive wavelength stabilization, temperature control, electrical control, all integrated into a commercial manufacturing line. The end result being a pilot line that you can then procure exactly the source that you need for your system. So this is what we think will be very necessary, whether your wavelengths are 360 nanometers or 639 nanometers or 1013 nanometers or all the way up into even longer wavelengths. What Daylight can do is go down into the fab, design the die, design it optimally with an eye towards the integrated module, develop a pilot line to develop those modules so that they can work in your system. So that's what we're offering to this community. We'd be happy to work with your teams to optimize the sources. The end result is sources that look very much like these small gold boxes, and we'd be happy to talk further about it.
Where do you see DRS Daylight doing helping the most in terms of impacting quantum in applications, so to speak?
Well, I think probably the best way that we can help is put together these sources and subsystems that involve stable frequencies and stable amplitudes in a very small footprint with a very high reliability. So addressing the need to scale it from kind of research grade sources and subsystems into commercial sources and subsystems. These modules that I'm showing kind of right here, where you have frequency stability of a part in 10 to the 7, but you have hooks to close the loop so that you can even do greater active stabilization, have 10,000 hours of lifetime, incredibly small swap, can be manufactured in a robust modular way. And if the quantum ecosystem, as it develops, it needs to have commercial, scalable, high reliability, low swap subsystems. And I think that's where we can help the best.
Great. Thanks, Tim.